You guys ready? Someone said no. Nicole, are you ready?
No.
Well, that blanket should be banned from being in here. No cowgirls allowed.
I got other Easter shirt.
Alright, so the first part of day 2 says you also need to be able to evaluate, which we know means what? Solve. We need to be able to evaluate expressions using your calculator. Round your answers to the nearest hundredth if necessary. Alright, so grab your calculators. Does everyone have one? Alright, so I'm going to type in the 7th root of negative 4,573. For us to do that, this root is way too high, right? I have to plug it in. So I type 7 first, then I go to math. I go down to number 5 so it can plug in that 7. And then I'm just going to type this in, negative 4,573. And I get negative 3.33 repeating, right? It tells me to round to the nearest hundredth. So that's what I'm going to do. My answer is negative 3.33. Well, for this, if it says evaluate this, I'm not going to make you do the factor ladder for 4,573. That's a little cool. Okay. Not that mean. Alright, back to your calculators. My next problem is parentheses 257 to the power of parentheses 5 divided by 3. Okay. On your test, if I want decimals, you'll see it in the directions that say like round to the nearest whatever. Alright, we get 10,388.57. So let's break that down. Oh wait, 56. That 6 makes my 5 round up. Alright, are we good with this? Thumbs up and a smile. Alright, this is where it gets real. Alright, here we go. Do we notice how under my radical, I basically have 3 different things. I have a number, which is 81. I have a variable, which is A, and a different variable, which is B. You guys see that? Those are all different things. What is my index here? Huh? My index is my root. It's 3. Okay, write that down. Your index is your magic number. Okay, that is your best friend. You need to know what that index is. Alright, so grab your calculators, and we're going to see if there is a cube root to 81. So I'm going to go to cube root, which is number 4, and type in 81. Do I get a perfect cube? No, we get decimals, right? We don't want decimals. Alright, so here's the deal. We have to do the factor ladder here. So off to the side, let's start with 81. The smallest number to go into 81 is 3. When I divide 81 by 3, what do we get? 27. The smallest number is 3. Divide 9. The smallest number is 3. Divide, we get 3. The smallest number is 3. We get to 1 and we stop. Alright, based on my index or my magic number, I need groups of how many? 3. Boom, I got it. Okay? That group of 3 comes out. What is left over in the radical? 3. So this is my answer. Okay? What we're going to do is we are going to rewrite this. So, let's draw your radical. Let's place your index inside. That's step 1. All we did was just rewrite my radical. Because we already simplified 81, I'm going to plug that in. The simplified version of 81 is 3 root 3. So my 3 is on the outside, there's my index, my other 3 is on the inside. All we're doing is just simplifying. The first thing we had to do is my 81, so we're done with that. Okay? Next, I have a to the 6th. That means I have 6 A's, right? Out of my 6 A's, I need a group of 3. How many groups of 3 do I have? 2. So guess what? Those 2 groups come out from under my radical, and I write them on the outside as A squared. I'm just breaking it down piece by piece. So my A's are now done. Because I had 6 A's and I needed a group of 3. I have two groups, so that means A, and then the 2 means how many groups I have. Then I have 9 B's. B, 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 B. All right, someone already said it. I have how many groups? We have 3 groups of B's, so that's going to come out as B cubed. I recommend you guys use a pencil when you do this, because sometimes we don't know exactly what's going to go under my radical and what's going to come out. That's why I just make it a long one. But this is my answer. Nothing else goes on the inside. If there's actual pairs, or sorry, groups, we pull them out. Any questions there? All right. Number 2. This says 2 times the 4th root of x to the 8th and y to the 12th. Okay? Right, so what's my index? My index is 4. That's my magic number. Right? What I do first is I want to rewrite my index and my radical. I'll worry about everything else in a second. Whatever is on the outside, if it's already there, we're going to leave it. This 2 is on the outside of my radical, right? So you leave it out there. Okay? Now, I have x to the 8th. So that means I have 8 x's. I need a group of 4. How many groups do I have? I have 2 groups. So that means that those x's are going to come out as x squared, because I have 2 groups. All right, my x's are done. I move on to my y's, and I have 12 of them. I need groups of 4, so how many groups do I have? 1 group, 2 groups, 3 groups. So that is y cubed. Do I have anything else that's left over? No. My 2 is outside, my x is done, my y is done. Is there anything left inside the radical? No. If you want to erase the radical, go for it. You don't even need it anymore. But we wouldn't have known that from the beginning, so that's why we always write it. But that's my answer, because everything came out. All right, so I made a mistake and I skipped over a problem. The next one we have 3x times the cube root of 512 x to the 7th, y to the 3rd. All right, so what's my index? 3. All right, I'm going to rewrite my radical with my index inside. What is on the outside? 3x is on the outside, so guess what? It's going to stay on the outside. I left some space because I know I'm probably going to have to bring some things out under my radical. So always give yourself some space. All right, now we have 512. Let's grab our calculators. Don't just watch me do it. I want you guys to do it. We're looking for the cube root of 512. So I go to math, I go to number 4, and I'm typing in 512. What do you guys get? What's the cube root? 8? Yes. So 512 is done. That comes out to be 8. Because it's a perfect cube, we just bring it right out. All right, so we're a pretty smart bunch. I'm not going to make you guys write out all the x's or all the y's or all the variables, okay? If you do that, you probably have a less chance of messing up. But if you want to divide, I'm fine with that, okay? So if I have 7 x's, how many groups of 3 do I have? I have 2 groups, right? So that comes out as x squared. If I bring out 2 groups, that's only 6. So I still have 1 left over. Where does that 1 go? It stays inside. It cannot come out because it does not have a pair or a group of 3. Okay? So my x's are done. Then I have y cubed. I need a group of 3. How many groups do I have? Just 1 group. You can write your 1 if you want, but you don't need to. This is not our final answer, only because whatever's on the outside, we need to look to see if we can combine it, okay? Just like terms. What I can combine is my numbers. So what's 3 times 8? 24. All I'm doing is just simplifying. I'm simplifying what's on the outside. Then I have x to the first times x to the second. So that gives me x cubed. That's basically a 1. And then my y is by itself, so that just comes down by itself. I still have the cube root of x. That is my answer. So far, so good? You guys aren't hating math yet? Yeah. All right. Let's take a look at this one. Bianca, what's my index? What did you say? Yes. 7 is my index. All right, so let's break this up into pieces. I know I'm going to have a radical and my index. Grab your calculators. If you have the 7th root of negative 128, type it in 7. I go to math. I go down to number 5, so plug in. And I have negative 128. You should get negative 2. Good. That negative 2 will come out here, because that is the 7th root of negative 128. All good? X to the 7, I need a group of 7. How many groups come out? Just 1. What about my y? Y to the first. This stays underneath. I don't have anything. It's not enough to bring out. It stays underneath. This is my answer. So I told you that you can erase if you need to, if you draw your radical too long. Or you can leave it. I don't care. But that is our answer. You guys understanding the gist of this? Good. Now this was interesting because this is why I told you guys I don't need you to draw out a million x's or y's, okay? I do not expect you guys to write out 20 or x 21 times or y 30 times. But if you do, I'm okay with that. Because once again, you probably will make less mistakes. What is my index here? 4. All right, that's my magic number. I'm going to go ahead and rewrite my radical and my index. Someone type in, what is the 4th root of 256? Is it 4? Someone double check, Bryce. All right, good. So I bring that 4 out, basically like free from jail. Okay. All right, so you can also do this in your calculator, which I actually like. When we're talking about x to the 21st power, right? Let's take this exponent and divide it by my index. So let's do 21 divided by 4. That first whole number tells you how many groups you're going to have, right? So I know I'm going to have 5 full groups. So that's going to be x to the 5th. And then let's multiply that to our index. So it's 5 times 4. 5 times 4? 20. I needed 21, so how many are left over? 1. That 1 stays underneath. You guys type in, what is 30 divided by 4?
7.5.
7.5. So I have 7 full groups, right? So we have y to the power of 7. What's 7 times 4? What's 7 times 4?
My bad.
28. So how many y's are left over?
2.
2 are left over underneath.
I'm not very good at that.
Okay? You could do it that way, or you could do it the way that I showed you. But that's our answer. Everything's done. Kaboom. Because what we're doing is we have x to the 20, because we had 21 divided by our index, right? And that gave us 5.20 something, I don't even know. This number, the first full number, the whole number tells me how many groups I have, right? So that's why I have x to the 5th. I know I have 5 full groups. I'm going to multiply this times my index. 5 times 4 is 20. I needed 21, so how many are left over? 1. Same here, y to the 30th. Out of 30, there's 7 groups of 4. 7 times 4 is 28. I needed 30 though, so there's 2 more extra. Okay? The shortcut, or you can write them out. It's always the easiest. Any questions here? All right, so now we're going to talk about write the following expression in 2 ways. What we did before was all we did was simplify. We didn't even get to the 2 ways. Okay? Now we are going to learn that part. This is basically a 3-step process. At first, what we're going to do is what we learned last class. Okay? I have the square root of 121 and x to the 12, y to the 7. What's my power on 121? 1. What's my root? 2. It's not in there, but I know that it's there. Okay? So let's rewrite this, okay? All we're doing first is rewriting. You guys have to do what I'm doing. Okay? Peyton told me the power on 121 was 1. My root was 2. What about x? What's my power? What's my root?
2.
Good. And then y
7.
over 2. Good. Do we remember that from last class? I hope so. That's step 1. When it says to write exponentially, what we're doing is we're taking what we already learned and we are reducing it. Okay, we're going to simplify it. In your calculator, what is 121 to the power of 1/2? $11. Good. So I'm going to write 11 here. All right, and then I have x to the power of 12 over 2. What's 12 over 2 reduced? 6. So x to the 6. And then 7 over 2, does that reduce evenly? No, so we just leave that. Y is 7 over 2. All we did was just simplify. We rewrote it, and then when it says exponential, we just simplified. Does that part make sense? All right, for the radical version, we're going to need a radical, okay? What we're doing is we are doing what we did today. For my radical, I'm looking at this, and I'm going to take out things that I can. What is the square root of 121? What is it? 11. And 11 comes out. Okay? Then I have x to the 12th. I need groups of 2. There's how many groups of 2 in x to the 12th? X to the 6. I'm doing what we just did today. Alright, then I have y's. I have y to the 7th. There are how many groups of 2? 3 groups of 2. And what's left over? 1. So this is my answer for radical. The radical version is what we learned today. We're taking out things that we can. Any questions here? All right, now we have the 5th root of 32 times y to the 11th and x c to the 12th. First, we are going to rewrite it. What is the power on 32? 1 over 5. Then I have y. What's my power? Over 5. And then we have z. 12 over 5. Good. Okay, that's just for our reference. I needed that to do my exponential. What is 32 to the power of 1/5? 2. All right, y to the 11th over 5, does that reduce? No, just write it again. And then z to the power of 12 over 5, does that reduce? Okay, we're reducing our fractions if we can. Anytime you have a number with an exponent as a fraction, put it in your calculator. All right, this last part here, I have a 5th root. Okay? What's the 5th root of 32? Anybody, what's the 5th root of 32? 2. Alright, then I have y to the 11th. So there's how many groups of 5? There are 2 groups of 5, so how many are left over? 1. Because that means there are 10, and we need 11. Alright, my z's, there are 12 z's. How many groups of 5? 2. And there's how many left over? 2. Okay, we have one more. All right, I have the cube root of 64 times a to the 9th times b to the 7th. Let's rewrite this. 64 has a power of what? 1. And a root. And then a has a power and a root. And then b, 7 over 3, right? All right, let's simplify that. In your calculator, 64 to the power of 1/3 is what? 4. Alright, a to the power of 9 over 3. What's 9 over 3 reduced? Yep, so a cubed. And then b, the 7 over 3 reduced evenly. No, so we just leave that. Alright, the last part here, I have a cube root. And I have the cube root of 64, and Nicole told us was 4. That is the cube root of 64. I have a to the 9th. There are how many groups of 3? 3. And then I have 7 b's. How many groups of 3? And how many are left over? Good. Are you guys understanding this? Okay, so here's what you're going to do for your classwork today, which you will also get points for. Turn to the day 1 that we already did, day 1 classwork. I want you guys to kind of draw a line. Okay, go to the boxes that have 7 through 12. Okay, at the very bottom. 7 through 12, so what we did earlier was we just rewrote it, right? But now we know how to actually simplify it, which is what your directions said. So Trace, you may not have room, or at the very bottom, you may have a little bit of room. Make this thing work. If you guys want to draw a line under what you already did, that's fine. If you just want to make some space, write it in pen, write it like a different color, I don't care. But you're doing 7 through 12 for your classwork today. And you're doing it the same way that we just learned. So the first one says,
Exponential or?
Nope, just this one, 7 through 12.
No, are we simplifying it exponentially or right?
You're simplifying it x or radical. Okay, so first you're going to see what's the cube root of 27, and then you have 6 x's. How many pairs of 2? Sorry, how many pairs of 3 will come out? Let's do this, and then we will go over the answers.